Set theory, long hailed as the cornerstone of modern mathematics, assumes a hidden certainty that doesn't hold up under scrutiny. That the concept of 1 is fixed, objective, and universal. But what if this assumption is false? This video argues that the entire edifice of set theory is built on a tautology, a blind faith in the self-evidence of 1, which collapses under philosophical and relativistic inquiry. Drawing on insights from quantum physics, relativity, Gödel's incompleteness theorem, and linguistic philosophy, we expose set theory's foundational flaw, the undefined and context-dependent nature of 1. Set theory began as an attempt to formalize the notion of number. Yet it made a fatal shortcut at the outset. It never defined what it means for one element to be 1. Mathematicians simply assumed that we could count things and compare their cardinalities without asking the most basic question. How much is 1, and of what? Instead of defining value, set theory defined membership. But what does it mean for an object to belong to a set if we haven't defined the size, weight, or meaning of the object in the first place? In simple words, set theory defined the size of a set by introducing elements. It says two sets are of same size if both sets have same number of elements. But what about the size of each element within the set? If the size of individual elements within a set are not uniform, then two sets with same number of elements cannot be said to be of same size. Can a set of 2 elephants and 2 oranges really said to be of the same size? Therefore, set theory is tautology, where the terms numbers, elements, and size are used interchangeably without adequately defining any of those terms. This silent assumption, 1 equals 1, always and everywhere, is precisely the kind of static notion that modern physics and postmodern philosophy have shattered. In set theory, the cardinality of a set is defined as the number of elements it contains. But this definition is deeply circular. The number of elements in a set is defined by counting, but counting assumes a prior, objective understanding of 1. This is the tautology that underlies set theory. 1 is defined by counting, counting is defined by 1, therefore, 1 equals 1 because 1. But 1 isn't always equal to 1. Consider, is 1 atom equal to 1 elephant? Is 1 drop of water equal to 1 ocean molecule? Is 1 event in spacetime equivalent to another? Clearly, 1 has no absolute value. It is not a universal unit but a relational concept, depending on the context and observer. The illusion of cardinality only persists because we ignore the subjective nature of measurement. Set theory allows you to define collections of objects without defining the objects themselves. A set of apples and a set of emotions can both be treated as abstract elements. But this collapses the distinction between measurement and comparison. Comparison tells us how many of something. Measurement tells us how much that something is. Set theory confuses the two. You can't meaningfully compare two things unless you first define or conceptualize what it means for one of them to be 1. The failure to define the value function of an element, how much one object is, leaves set theory in an ontological void. Relativity teaches us that space and time are not absolute. Events occur differently in different frames of reference. Similarly, the value of a unit, 1, must also depend on its context. In fact, we may state a general principle. The value of 1 is not fixed but relative to the observer's frame of reference. In this view, every number is an informational construct. Numbers, like measurements, are not objective quantities. They are contextual judgments made by observers. Any foundational system, like set theory, that assumes otherwise rests on an outdated metaphysical worldview. Gödel's incompleteness theorem revealed a terrifying truth. no consistent formal system can be both complete and self-contained. Set theory, like arithmetic, is no exception. But Gödel's deeper implication was philosophical, not just technical. Any system that assumes complete knowledge of its own definitions will eventually collapse under the weight of its unexamined assumptions. Set theory's Achilles heel is its assumption that sethood is definable without first defining value. That is, you cannot define size without defining what 1 is. And you cannot define 1 without appealing to external frames of reference, meaning set theory isn't foundational at all. It depends on meaning imported from outside its own system. Set theory is not evil, nor useless. It simply began with a flawed premise, that numbers have intrinsic meaning. What we need now is a paradigm shift, from sets to monads, from objects to information, from static truth to dynamic understanding. The question is no longer, how many are there? But rather, how much is one, and of what? Until we can answer that, all sets are built on sand. If your mind enjoyed this, engage with Braingasm pages, like, share, comment and subscribe.